Darwin and the Darwinists claim to defeat a certain form of teleology, the kind of Platonic teleology. And as you probably all know, that this is the kind of teleology where we presuppose a craftsman who organizes things, who creates life and all that. Or we can also go back to this very famous watchmaker example from Paley and natural theology in the 19th century. So we can also talk about the watchmaker, which is a topos in the theory of biology. So that was the kind of teleology that was created, planted by some higher being, God or whatever, that was criticized or rejected by the Darwinian perspective. And I'm not sure whether Donny would agree, but it might be the kind of spooky teleology, this Platonic teleology that usually people talk about when they talk about a kind of teleology they don't like or want to reject. I'm not sure, but in the biological context, it's quite plausible that they talk about something like this. Now, the rejection of Platonic teleology doesn't mean that we can reject all kinds of teleology. So some kind of immanent Aristotelian teleology, which attributes some principle of immanent principle of change to living things or stuff like that, is not something that's necessarily rejected by the new Darwinism or modern biology. And we shouldn't say, however, that it's straightforward that we should use this language. So the teleological language is in itself became problematic after Darwin, but the distinction between the basic distinction between Aristotelian and Platonic teleology is still relevant, because many of the founding fathers of modern biology, first half of the 20th century, middle of the 20th century, were quite sympathetic to talking about teleology in the biological context. They meant different things about that, but to some extent, they all talked about something like this Aristotelian thing, some kind of an immanent feature of those things that they talk about, and usually they try to naturalize the notion, but there are different ways of doing that, and the dominant way of doing it is the way the paper talks about. Now, there were many problems with trying to naturalize teleology. So I won't go into any of these things now, but in the early days, even after Darwin, there was a kind of vitalistic approach where the teleological aspect of living things required some kind of a, let's say, ontologically emergent property. Sometimes the whole thing was the teleological notions were rejected because they were considered to imply some kind of mentalistic content, some kind of intentions or mental contents like that. Many were suspicious about the language or the whole thing because they thought that it presupposes some kind of a backwards causation. We already talked about this in other sessions. So where the goal, which is in the future, somehow has an effect on the past. And then especially vitalism and backwards causation seem to be incompatible with mechanistic explanations that are really important for modern science. So the whole general notion of teleology and teleological explanation was treated with suspicion in general for at least some good reasons. But slowly this picture that the paper talks about emerged, where and it became basically the received view, where we do think that natural selection explains everything that teleology was supposed to explain originally. So whenever we talk about a biological function and we try to explain it in a teleological manner, so we say that the feature is there because it serves a certain kind of functional purpose, then this whole language can be translated into the language of natural selection and those processes that underlie natural selection. So what natural selection really explains is the existence or prevalence of certain biological traits in populations, and in the context of such explanations, the most accepted view is that a function, a biological function, is kind of selected effect of a trait. And those who basically approach the whole problem from this perspective, they try to naturalize teleological language in a way that try to look for truth makers in natural in the realm of natural processes for this language. So basically, they try to encompass those large-scale mechanisms that create these evolutionary functions, and to utilize those as truth makers for teleological language. Now, the paper talks about two different notions when it comes to function. It talks about this natural selection-based or selected effect account of biological functions. And it also talks about the so-called causal role model of biological function. And only one of these is a good candidate for reinterpreting teleological language, or yeah, so basically for the project I just talked about. So let's talk about the etiological model, the selected effects model. So in this model, whenever we talk about a biological trait, an organ or whatever, we always highlight one effect that belongs to that trait. That's an effect that objectively belongs to a trait. And it's not an arbitrary move. So if it's not an arbitrary move, what allows us to highlight one of the effects that this trait can produce? Because most traits can produce like maybe uncountable different kind of effects. And the answer is that the highlighting is done by natural selection. So there's this example in the paper of a red flower where the color is advantageous in terms of attracting pollinators. Pollinators are attracted by the red flower or the redness of the flower in a context where other available traits in the population are less attractive for the pollinators. So such a theory can answer about 4 questions, where we say that the redness is there to attract pollinators. And the whole account is basically historical. It goes back to the selection history. But this is only one notion of a function utilized in biology. There's another notion of function that's also quite important, the causal role model of a function. And then what's important here is that this other notion, the causal role model of a biological function, is construed in a way that's not conducive to our project of understanding teleology. So the causal role model is basically a non-teleological model of function. And that will be important for distinguishing between traits that are teleological from this biological perspective and those that are not. Because if we accept this basic approach where teleology is basically anchored by a natural selection processes, historical natural selection processes, then we have to distinguish between traits that are teleological or can be rightfully described in teleological language, those that are not. So a causal role model, what you do basically is first you identify a whole, and then some parts of the whole can be described as having a function in the working of the whole. But this whole also, as previously, has like loads of different possible effects objectively. So to be able to identify the causal roles and the functions of its parts, first you have to single out the capacity of the whole that really gives you a criterion to decide on the contribution of the parts to that ability. So it's a kind of part-whole explanation, and in the context of mechanistic explanations, which is a really like burgeoning, growing field in the philosophy of biology and not only biology. This notion is worked out quite nicely. It goes back like far away to Harvey's time, but if you want to read a good present-day discussion, then you should go to and read some of the works of Carl Craver, who worked out this in a really precise manner. So basically, we are dealing with the part-whole explanation where the whole has a capacity we are interested in. So our choice of the capacity of the whole is probably arbitrary. But relative to that, we can decide on the contributions of the parts. And the contribution of the part to that ability of the whole is its function. Now, this notion is wholly ahistorical. The only relevant things that you have to consider from this perspective is the functioning of the present system, the system you're interested in the present, in its present context. And not only because of that, but mainly because of that, in this context, we cannot attribute a purpose to the trait we are talking about and the effect of the trait we are talking about. It's not there for a purpose from this perspective. It's there, but not because it serves a purpose. Okay, now we see the two different notions and the most important differences between them. And then we can turn to this problem of self-organization. So the reason why the paper talks about this is that it's a quite basic and important problem in biology, that there are many traits of biological entities that don't really have an evolutionary function in the sense we just talked about. Those traits are there basically because of some physical chemical constraints, and those constraints cannot be just avoided, or you can't get around them. There are some developmental pathways, there are some constraints that you have to conform to when you want to develop just any kind of system, any kind of living system. And in the paper, the notion of a generic properties is the notion that tries to bring you closer to this problem. So what is a generic property? A generic property can be defined simply as forms or morphologies that are highly probable given the dynamics of the developing system. So the whole notion of a generic property is usually tied up with ontogenesis, with the development of an individual from some kind of an initial form to an adult form or something like that. And then on this pathway, there are certain developmental constraints that are not really biological, they are more physical or more chemical, that you cannot avoid. Now, this is the kind of field that's called self-organization in this paper, where there are certain processes that organize themselves in a quite complex manner if you put them under the right circumstances. So I'm not sure whether everybody is familiar with the idea of a boundary condition that does serious work on chemical processes or even physical processes. So many of the dynamics we see in physics, in chemistry, in biochemistry are such that they only appear, they only come about when they are put under certain constraints, squeezed by certain boundary conditions. And then these self-organizing, these pathways through which you can somehow see the development of a kind of spontaneous order that's not really coded in any straightforward sense, is what's really interesting for us now because of this problem of having or not having an evolutionary function. So why is that? Many of these generic properties the paper talks about are basically byproducts in some sense of the developing system. Byproducts in the sense that without having those phases or without developing those intermediary states, in some cases, you just can't get to other, in some respects, evolutionary important traits. You have to have those to be able to have other states. And then the reason for this is that basically the way a biological system comes about is not like everything, all the measurable characteristics of the systems are coded by genes. You have like loads of possibly measurable characteristics of all living systems, but you have far less genes than those. So not all traits we have, not all features we have are coded by genes. Genes code much less than that. Somehow, what really happens in development is that the developmental process develops constraints that put pressure on other processes also initiated by the developmental process. And those constraints create the circumstances under which other things can develop into useful things. But these constraints or these things, the interactions between these things are what are really coding, if that's meaningful. It's even more metaphorical in this context. The traits we want to have. These things are not written into the genes themselves. And then these developmental pathways that are full of these byproducts or intermediaries are what we have to make sense of. We have to account for them. Now, the question is how to account for them, and in terms of which notion of function can we account for them. It's straightforward that the CR function, the causal role model based function, can be attributed to any kind of system. So whatever we talk about as a generic property in a system can be analyzed in terms of that function. So let's talk about prenatal or really early phases of whale development. Like whale babies have teeth, but later they lose those teeth and they develop into something that they can use in adulthood. That's just a kind of vestige of the evolutionary process, the long-term historical evolutionary process, at the end of which we have a whale. And it's a kind of intermediary state that's there, and then it's utilized to get to the trait that we really need. It really does the job in the normal life of a whale. So we should consider similar kind of examples. And there are others in the paper, as you know. So CR function can be attributed to any such things. It can be attributed to basically any aspect of a living being, but that's not true about the selected effects function. And then this whole idea of a generic property and its relation to natural selection is important, because we have to decide whether all traits or only some traits are subjects of natural selection and can be rightfully talked about in terms of teleology. Now, the paper basically closes with this idea. I will just summarize it in short, that it's possible to have generic properties where selection plays a role, because many of the generic properties that we have in nature, the favored example in the paper you might remember is the color, the pattern of a butterfly's wing. So this intricate pattern is a kind of generic property, but that doesn't mean that there aren't any parameters that determine the exact pattern. So it's not that the exact pattern is coded in the sense that every pixel, as in a picture, is coded by genes. The generative program is coded, and then you can get to other patterns by changing that basic code, but it's not like you can move from a pattern which is only one pixel away from the other pattern. So changes in the the generative program are quite different. So you get to different kind of overall or large-scale changes when there's a change in that. But still, there are parameters that determine the exact pattern, and those parameters can be subjected to natural selection. So it's according to the paper, even though there might be loads of such generic properties that don't really have an evolutionary function, it's not impossible that the initial parameters of such kind of a generative pattern are not set are set by natural selection. And then the epistemological issue, whether we can decide that a certain trait was subject to natural selection or not, it's a really complicated issue. The paper alludes to that, but from a kind of ontological perspective, the important message is simply that we have to be careful, because it's possible that a generic property is such that it has a teleological account. It's such that it should be described in a teleological manner because it was subject of natural selection, but it might not be the case. Is this clear, or is this?
Yes, I think it's very clear. It's still, I mean, I still have a number of worries, and if people are not asking questions, then I'd like to share some of them. I looked at some of the arguments against the causal role view and the selected effects view, and I'd like to ask your opinion about these sorts of classic counterexamples, because I take it if neither of these approaches work, then putting them somehow together won't work either, presumably. Let's start with the selected effects view. Here's an alleged counterexample to that. Imagine different types of ball bearings, some of which are smooth and some are rough. Suppose they are all rolling down an incline with various gaps in it. The smooth ones roll faster and tend to successfully cross the gaps. The rough ones tend to fall into the gaps and perish. Suppose, moreover, that when a ball bearing successfully crosses the gap, it enters a mechanical cloner device that spits out two identical bearings. Over time, the average smoothness of ball bearings would start to change. This is something like a selection process, but it seems counterintuitive to say that the smooth ball bearings have the function of jumping over gaps.
I think that's a quite nice counterexample. So I don't really want to defend this account of teleology here. I basically wanted to introduce the received view. I wasn't sure whether people really are really familiar with this, but I really wanted to bring it to the table because there are definitely some holes in the story, and I don't think that this is the best account of teleology in the context of biology, by the way. But I think that's right. So you can talk about selection stories without life and without living beings. I think that's right. And then that's really counterintuitive. But it's only counterintuitive if you presuppose that you need to have life for such kind of processes. I'm not sure that you have to have that. But I think you're right. It's weird because why would something that is not a living being have such kind of functions? So selected effects in terms of selected effects.
All right, let me move on now to the other account. Here's a counterexample to the causal roles view. This is from Justin Carson's critical overview of biological functions. Roughly, the causal role model says the following. I'm simplifying a little bit, but it's basically what's in the text. The function of x in S is to F if and only if S's capacity to G is partly explained by X's capacity to F. Garson mentions two counterexamples. The first comes from Ruth Millikan, and the gist of it is that according to this definition, the function of clouds is to promote vegetation growth by causing rain. And the second counterexample is that the function of myelin degeneration is to cause paralysis. Isn't that a problem for the causal role model? I mean, isn't this pretty much a reductio of the view?
And it's quite interesting that I don't really have, so in terms of so-called Cummins or causal role functions, I don't have much problem with the cloud example. Mm-hmm. So what's your system, what's your whole? If your whole is the biosphere or something larger, than the cloud itself, and it includes a river, forest, and whatnot, that's your chosen whole, even if it's called it's selected arbitrarily. Yeah, well, I think you should select less arbitrarily than that. But if that's your whole, then you have to first identify an ability this whole has, and if it has an ability, and then you can show that there's something the cloud does. There's a property of the cloud that contributes to that ability of your whole, and that's its function. That's its function.
I mean, I understand that you can use the word function in such a way, and well, I'm not objecting to that. It's just that if you use function in this way, you're just using function to denote some sort of causal role, something causes.
Yeah. And this is the reason why.
Why would you call that a function, really?
Yeah. Maybe you shouldn't call it a function. So the causal role model is called causal role model for a reason, and then that's really good analysis of part-whole relations in general, independently of biology. You can use it in all kind of contexts. It's quite useful. But you're right, and I think the paper we just read also says this, that this is not a notion of function that can make sense of teleology, or that can make sense of teleological language in general. That's not what we expect from teleology, that's for sure. So what do we expect? In general, we expect that we can explain the presence of something by attributing a purpose or a goal to something else. So in general, we can talk about, in the former example I just used, the redness of the flower in terms of teleology, because we think that it's there because it served a purpose. The problem with that account, or the more general problem that people usually raise, is that it's there because it served the purpose. What we don't really know, or what is not really necessary, is that it still serves the purpose. Maybe at present it doesn't really serve any purpose, and to be able to pin that down, to point out that factually at present this thing doesn't serve this purpose, you have to utilize the other accounts. So from a causal role perspective, you can analyze the system as it is situated in this present environment, and you can see that, okay, but at present, this trait we are talking about is not advantageous to it at all. So it's just not doing the work. Pollinators are not coming. It might be because there are no pollinators. It might be because pollinators changed and they prefer other colors, whatnot. But that's a different issue. So still, you might want to say, at least, you know, in this theoretical context, people have to say that redness is still there because of the past history, because it was selected in past generations, and maybe because of an accident, maybe because I don't know, some of the huge you know, agricultural companies started to use something like a horrible chemical, I don't know which. I'm not really an expert on that, and then most of the pollinators died out, and there's only one pollinator left, and that prefers white colors, and that happened this year maybe. And then, well, and that sucks for the flower, because then it cannot attract cannot attract efficiently the only remaining pollinator, but still the color is there because of the past history we are talking about. So it's weird, because I would say, why is this flower red? It's red because redness, you know, in normal or intuitive teleological language, is good for the flower. It's not good for the flower at present. We know that because we analyze the system in terms of causal roles. So at present, redness doesn't really serve this function of attracting pollinators. So it's not good for the being. Well, that's the problem, because past success or past advantage is not something that necessarily confers present success or future success.
Right, but I mean, it seems possible to construct thought experiments in which both of these accounts fail. So even though intuitively there are functions present, so think of Davidson's Swampman. So the lightning strikes the swamp, and an identical copy of Donald Davidson assembles out of the organic material in the swamp. That guy doesn't have an evolutionary history, so he doesn't have selected effect type functions. And let's add to the story that Swampman comes into being in the presence of Medusa, you know, the monster that kills you when you look at it. And so if he uses his eyes, he dies instantly. So being isn't good for him. So his eyes don't have any functions. But I mean,
I wouldn't say the eyes don't have functions function in this context. So again, you don't have an evolutionary history, that's for sure. The Swampman cannot be really described in evolutionary terms, so that's out of the picture. But you can talk about it in terms of causal roles. So if it's part of a larger system, you can talk about it as something that serves a function in that larger system. That's one thing you can do, and you can talk about its eyes in the actual context. So you can say that having an eye in this really unlucky context. So you were just created out of the swamp in front of a horrible monster that, you know. Well, in that context, having an eye, it sucks. But in terms of the causal role model, you can't really talk about advantages and disadvantages. The only thing you can say is that having an eye has a role in petrification. Mm-hmm. So it got petrified because it had an eye. Mm. So an eyeless Swampman would have had a better fate, or well, that's true. That counterfactual is true, but that doesn't have anything to do with the causal role analysis. The causal role analysis simply tells you that, yeah, in that context, eyes contribute to petrification. That's it.
We have a question in the Q&A box from Hiruko. Could the boundary conditions that create intermediary conditions in the causal role model be thought of as emerging from external conditions and not just endogenous developmental, biochemical, or biological conditions? If so, could the causal role model be used to explain misdevelopmental or pathogenic social developments in the organism that have diverted it from what we could understand as its teleological aim?
So the causal role model has a serious disadvantages. It cannot really incorporate talk of misfunction or any malfunction in general. So so when you ask about misdevelopment or pathogenic social developments, I think you're asking something that is not really compatible with the causal role model. Asking about something that's not really compatible with the causal role model. The reason why it can be so indiscriminative and can be applied to any kind of system you want is that there's no basis for attributing expectations or norms in the context of the causal role model. So a system works the way it works. A part contributes to it the way it contributes to it, and whatever it contributes to it. If we don't like the outcome, we don't like it, but that's on us. It cannot be attributed to the system as a failure. So I think that's one important thing. Yeah. So the boundary conditions issue, I'm not sure why it is important for you, but in the causal role model, being indigenous or exogenous, so the boundaries of the system are basically quite arbitrarily drawn. So if you want to include something into the system, you include it into the system. The causal role model can't give you justification for your decision concerning boundaries. I'm not talking about boundary conditions, it's about boundaries of the system. You have to have some external justification for singling out your entities of interest or systems or whatever. So I'm not sure that that's really meaningful in that context. But so whether boundary conditions that create the intermediary conditions, I think we can talk about that in other contexts, and then this might be a point where we can just forget about the context of this paper, and we can open up to other possibilities, because so the causal role model of functions, I think Donny is absolutely justified in asking this question, is just too indiscriminative to be taken seriously by people who are interested in teleology. That has nothing to do with teleology. It has to do with part whole explanations. I think that's the best, that's the simple shot on this. The other notion, the selected effects account, the evolutionary history-based account, it also has some shortcomings. There are certain things it cannot talk about, it cannot incorporate. And what it cannot incorporate is something it presupposes on the other hand. So talking about selection histories, we presuppose the existence of individuals, and we talk about living systems, usually living systems that are organized in a certain way. And that organization they have might allow us to talk about teleology in another respect or from a different perspective. And I think that's what the paper misses, and that's what, even though it's discussed in the philosophy of biology literature, is not really part of the received view. There are a few writers who published on this recently. For example, Mossimo has a 2015 paper. I would suggest to people who are interested in this. But so some people started to go back to early cybernetics and systems biology, and try to talk about teleology in a different sense. And what they want to tell us is that Darwin is a really important contributor to modern biology, but there's at least another tradition that allows us to somehow naturalize teleology independently of Darwin. And that tradition goes back to Claude Bernard and his idea of an internal milieu of according to that basic tradition, living beings are capable of maintaining and conserving their internal milieu. The internal milieu is basically a state of a system that stays between certain parameters, from pressure to the amount of water or density of this or that protein, I don't know what, whatever is interesting for a particular biological system. And then this capacity of the system to conserve this internal environment in a certain way is what might ground another sense of teleology, or another notion of teleology that's also a kind of naturalized account. So what's the basic idea there, or how should we think about it? In that case, we don't have to, but we can't forget about natural selection. We can go to Donny's swamp monster that was just created by accident. When it comes about, as we already talked about it, it can be analyzed from the point of view of the causal role model, but it can be also analyzed from the point of view of this systemic approach, where it can be objectively decided whether this system is such that the processes it goes through are first cyclic, so there is a causal cycle that goes on and on inside this system that somehow interacts with the outside world as well, but there's a cycle, that's one thing. And whether that cycle is self-maintaining, so it goes around, and because it goes around, it can go around again. Sorry. So that's a quite important issue, but it's not enough to be able to talk about biological teleology in an individual. For a simple reason, there are counterexamples to it. So you can simply say that there are hydrological systems on Earth that are cyclic in a quite similar manner. So there's the river goes into the ocean, the ocean's water evaporates when there's heavy sunlight, and then there's cloud formation. The clouds travel back to the continent. Some of the great mountains trap them, and then there's rainfall, and that rain goes back to the river. And then this is a kind of self-perpetuating cycle. But there's nothing like living, and it would be similarly weird to say that the reason why there's rain is so to give a teleological account of rainfall, let's say, in this system. So to say that the reason why there's rain is to have a river. You wouldn't be really happy with this account, would you? But you can add one further criterion, and then some of these people I mentioned thing that would be sufficient for identifying systems that are somehow inherently teleological. So a river has boundary conditions. It flows between boundaries in a straightforward, everyday, literal sense. The same is true about all the other parts of that natural system. It interacts with the boundaries, but it doesn't really maintain the boundaries that are required for the maintenance of this system. So without the mountains, without the mountainsides, without the river banks and all of these things, you wouldn't have the hydrological cycle in place. But none of the parts I described in the process, none of the phases of the process are such that they contribute to the maintenance or the existence of the boundaries. They interact with the boundaries, but they don't maintain them. So the idea is that a living system is really a kind of system where there's a kind of self-perpetuating causal cycle, similar to this non-living example I just gave. But the cycle is such that parts of the system not only cause other parts to engage and do their work, they contribute to the maintenance of those boundary conditions that are required for this causal cycle to go on. So, and the parts basically contribute to the conditions of existence that are important and indispensable for this system. So let's just try to give some examples. If you're a living system and you require water, then you have some water intake, and then if it's high and you take in a lot of water, your system will distribute it in a way that maintains a certain level of water in all cells of your body. It will remain in a certain range. If your water intake is quite low, it will do its best to maintain the level in the same range, independently of what happens inside. And then the cycle that goes on inside of you, so all of the maintenance cycles you have, do this somehow, maintain this level of water in this range. Not only in a purely mechanistic causal sense, but also in a sense that can be said to be teleological. So it basically maintains itself by contributing to its own conditions of existence. Am I making sense? What do you think, Danny? Is this clear?
Yes, it's clear. Does this view have a name?
Well, I think there's no settled name, but I think in most of general systems theories in biology, you have something similar. So I can give you many names for this, but I think the best name in the literature now, maybe, or the most prevalent, is self-determination and self-constraint. Both of these are used. So when they talk about self-determination of a system, they usually talk about this kind of teleology that basically grounded in this self-maintenance of a system. So what really happens in a living system. In a living system, all parts are such that they contribute to their own existence conditions. So in this sense, they have a telos, and their telos is to survive to the next moment, basically, to the next cycle of self-maintenance. And they do this by utilizing their inputs in a way that the output will help them to do another round. So I think this is maybe the most interesting notion of teleology at present in the literature, and I think it is because it's quite easy to attribute this kind of teleology to the system itself. So you can talk about these features in a quite serious sense. So you can say that belongs to the system. It is its own structural feature. It is something that's immanent in the system. So I think if we go back to this Aristotelian notion, I talked about it in the intro to the paper. So I think this old Aristotelian notion is best somehow utilized in this context, and at least in the philosophy of biology, that's the case. So self-determination, and there's a reason why they also call it self-constraining, are the notions that can ground a kind of Aristotelian teleology quite nicely. And what's really good about this account is that you don't really need evolutionary histories for it. So it's an independent account of teleology, and can be applied to your swamp man as well.
Thank you for the question, Hiroko. Our time is up, unfortunately. So thank you, Gergely, for this very interesting session.